Hello students, welcome back once again. Today we are going to study the second type of distribution, that is binomial distribution. Again, this is also a discrete probability distribution, and this is just the extension or one step further from the previous one that we had studied, that is Bernoulli distribution. Now, what is so special about binomial distribution? Definitely, in the previous distribution, that is Bernoulli, we saw that any experiment has only two outcomes, either a success or a failure. When a child is born in a family, whether it is a boy or it is a girl, when an item is picked from the bag, whether it is correct or not correct. This was all we saw in Bernoulli distribution. But now, what happens in binomial distribution? In binomial distribution, what happens is, definitely, again, there are only two outcomes, which is a success or a failure. And we said success and failure are represented by P as well as Q. But here, in binomial distribution, as I told you, we go one step further, that is, what if 10 coins are tossed? What if 20 coins are tossed? What if 25 coins are tossed? What happens that time to the probability? We know when one coin is tossed, it will either be a head or be a tail, either be a P or be a Q. But what happens when 10 coins are tossed, 12 coins, 15 coins, 20 coins? Number of coins whenever it is increased or number of people when it is increased, what happens is we get one more parameter, and that is why we call it as binomial distribution. That means binomial distribution has two parameters, namely n and p. These are the two parameters which are there in a binomial distribution. N is nothing but number of trials, that is nothing but say a coin. We talk about 10 coins, so n will be 10. We talk about tossing the coin 20 times, so n will be 20. We tell that in a bag of 50 mangoes, that means n will be 50. In this way, n is nothing but the number of trials. Again, P and Q are nothing but success and failure itself. And the rest of the procedure we will look forward when we are going through the binomial distribution. Understand students, binomial distribution also has something called probability mass function. And what is the probability mass function for a binomial distribution? It is nothing but, again, P of x is equal to x equals to P of x is equal to, it's a combination NCx into P to the power x into Q to the power n minus x. As usual, don't forget to write the range. Here the range is x is equal to, what will be the range? For Bernoulli, it was 0 and 1 because there were only two outcomes, a success or a failure. But here we have number of trials, so it is 0, 1, 2 up to n. That means we can have n number of trials. And this is the probability mass function. Two things to remember here. Don't forget to write the range, x is equal to 0, 1, 2 up to n. And secondly, remember any probability that for that matter lies always between 0 and 1. And as usual, you know what is Q? Q is nothing but 1 minus P. As usual, Q is nothing but 1 minus P. So remember students, this is binomial distribution. Going further, we will look into the properties of binomial distribution. Okay, Let us look into the properties of binomial distribution now. Binomial distribution has various properties. Let us go through them one by one. Firstly, you should know binomial distribution is what kind of probability distribution? It is discrete probability distribution. That means it has certain specified values to it. Next, what are the parameters? As the name itself suggests, binomial. That means the property of binomial distribution says that it has two parameters, and which are those? Those are nothing but n and p. These are the two parameters of binomial distribution. We already saw the PMF, which is nothing but P of x is equal to NCx into P to the power x into Q to the power n minus x, and also we wrote the range, nothing but x is equal to 0, 1, 2 up to n. Remember students, n is always a finite number. N is always a finite number. Next property of binomial distribution, and very important, is as we saw in Bernoulli, we need to know what is the mean, variance as well as standard deviation of binomial distribution. Firstly, let us see what is the mean. Mean is nothing but, in Bernoulli it was one parameter, and that is why the mean was p. Here binomial has two parameters, namely n and p. So mean is equal to n into p. Variance is nothing but n into p into q. What will be the standard deviation? As usual, very simple. Standard deviation is nothing but square root of the variance. And what is the variance? N, P and Q. So it is N into P into Q. Okay, the next property what we'll talk about is the symmetry. Now what do we call a symmetry? Symmetry is nothing but when the things are equal. That means whenever your probability is equal to 0.5, when P is equal to 0.5, what will be the value of Q? Even Q will be equal to 0.5 itself. There is nothing but, remember, whenever P is equal to Q is equal to 0.5, we call it as the distribution is symmetrical. Is symmetrical. This is what we say whenever P and Q are the same, which is 0.5. Next, and the most important property is nothing but about the mode. Now understand students, here in mode there are two cases basically. The first case is nothing but, case 1 is nothing but if n plus 1 into p is an integer. Now what do we mean by integer? Integer means a fixed number. That is, whenever I do n plus 1 into p, when I multiply, if I get the answer as 5, if I get the answer as 6, if I get the answer as 8, 12, 14, that means a fixed number, a whole number if I get, then mode will be nothing but, it will be bimodal. That means there will be two modes. When will there be two modes? Whenever n plus 1 into p is an integer, that means a proper number, that time binomial distribution will have two modes and it is called bimodal. And which will be the two modes? The two modes will be, one is nothing but n plus 1 into p itself. This is one. and one more will be similar to this, n plus 1 into p square brackets minus 1. These will be the two modes whenever n plus 1p is an integer. Okay, let us see what is case 2 now. Case 2 is nothing but whenever n plus 1 into p is not an integer, that means n plus 1 into p, when I multiply, I will get the answers, say 6.35, 5.76, 9.15. Whenever I get answers in points, that means it is not an integer, it is not a whole number, and at this point, students, binomial distribution will have only one mode. There will be only one mode. And what will be the mode? Mode will be nothing but n plus 1 into p, whatever answer we get here, only the integral part of it, only the integral part. That means if in case you get the answer as 6.33, then the mode will be 6. If you get the answer as 7.17, then the mode is 7. In this way, this property of mode case 1 and case 2 become very important. Next property, let us see. Next property says, when does binomial distribution tend to the next kind of distribution? That is nothing but, when will binomial distribution become a Poisson distribution, or a binomial distribution tend to Poisson or Poisson distribution? When will this happen? This will happen in a case where two conditions have to satisfy. One condition is that number of trials, that is n which we saw, the number of trials n which we saw, this has to tend towards infinity. That means what I was talking to you about, 10 coins are tossed, 20 coins are tossed, 50 coins are tossed, it is okay. What if 100 coins are tossed, 200, 300, 500 coins are tossed? The data becomes large. It will be very difficult to calculate. So, whenever n tends to infinity, as well as one more condition should satisfy, that is when p tends to 0. That means the probability value will keep on getting less and less and less and less. That means the success ratio will keep on being less and less and less and less. So, whenever n goes bigger and bigger, that is tends towards infinity, when the value of probability or the chance of success keeps on going less and less and less, that is towards 0, binomial distribution tends to Poisson or Poisson distribution. In the same way, there is a chance that binomial distribution might as well tend to normal distribution. We will see about this. That is nothing but we are talking about discrete distribution, binomial, tending towards a continuous distribution which is normal. Well, when does this happen now? This happens also in two cases. First case is nothing but n definitely has to tend towards infinity. Now you will definitely have a question, sir, here also you are telling n tends to infinity, here also you are telling n tends to infinity. Yes, both the places n tends to infinity condition should be there, but if binomial has to tend towards normal distribution, then understand students, the value of P and Q will be almost equal. Almost equal. This is very, very important to know. Here the value of P was being less and less and less. That means the success ratio was coming down. But when binomial is tending to normal, n will be tending towards infinity, but the value of P and Q will be almost equal to each other. Say when P is 0.5, even Q will be 0.5. Maybe if when P is 0.51, Q will be 0.49. If this is the condition, then binomial distribution will tend to normal distribution. So understand students, these were all the various properties of binomial distribution. Apart from this, you will have one more property which is to be known, that is nothing but what if a lot of total frequency is asked to find out. Total frequency we know in frequency distribution. What is the letter to represent total frequency? Correct. Capital letter N. This is what we call for total frequency. So that means whenever total frequency is asked to find out, our formula becomes nothing but N into the probability mass function. That is nothing but total frequency can be given by nothing but N into what is the PMF of binomial distribution? It is small letter NCX into P to the power X into Q to the power N minus X, comma, X is equal to 0, 1, 2 up to N. This is nothing but the total frequency whenever it is asked. This is the way to find out. Okay students, so these were all the properties of binomial distribution. Let us look into a few problems on binomial distribution.